Study Unit 6, Lecture 6. This lecture considers a phenomenon known as overlap, and it occurs when the signal source or the supply voltage which is supplying current and energy to the load in a converter is non-ideal. Up until now it has been assumed that all the thyristors and diodes which are used in these converters and rectifiers have been ideal. In other words, these thyristors will turn on and off instantaneously. This is of course not true, and there is some transient behavior which exists for these types of devices. This transient behavior is modeled as a reactance in series with an ideal source. So in the simplified example over here, there are only two thyristors which are considered in order to model the transition from switching between one thyristor to the next. This reactance, which is present in series with the ideal source, resists a change in current through the thyristor. What this means is that there is now some kind of delay or transition which must first be completed before the two thyristors operate in the expected manner, with one being completely off and the other being completely on. So this transition between the two thyristor switching is shown over here as a notch or a byte out of the idealized waveform. It is during this notch that the switching transitions from one thyristor to the next. Coming back to this expanded model, which includes the reactances for the thyristors, there is some current I which flows between the thyristors during this transition period. If the line reactances are identical, then for some constant current output, the inductor changing currents are equal and opposite, and the output voltage during the computation is midway between the conducting phase voltages V1 and V2. So in simpler terms, as this thyristor stops to conduct, there will be a jump in notch. In the ideal case, this would continue directly up and cause thyristor 2 to turn on, but instead halfway between the two voltages there's first a notch before completing the transition and conducting through the second thyristor. The length of this notch in terms of the switching cycle is called the overlap angle. And the reason why it's called the overlap angle is simply because during this period when the notch is present, both thyristors are conducting. The thyristor overlap angle is determined as follows. Firstly, V2 minus V1 is defined as being equal to 2L didt, where L is the reactance in each line of the converter. If the time at which T2 starts the trigger is set as T equals 0, then V2 minus V1 can be written as simply the voltage over this inductor VL, and this will be equal to root 3 multiplied by root 2 multiplied by V sine of omega t plus alpha, where alpha is the delay angle. This expression for V2 minus V1 can be equated to this expression over here, and the differential equation can be integrated to give I of omega t equal to root 3 multiplied by root 2 divided by 2 omega L multiplied by cos alpha minus cos of omega t plus alpha. The commutation is said to be complete when all the current flows through a single thyristor. In other words, when I of omega t is equal to the average output current, then the average output current can be expressed as 2 pi V out divided by 3 omega L multiplied by cos alpha minus cos alpha of gamma plus alpha. This equation will hold true for small values of gamma, in other words gamma less than pi over 3. The presence of this overlap and the angle gamma will have a direct effect on the expected output voltage of the converter or rectifier. This equation shows the output voltage in terms of gamma. If gamma was 0, then this equation would reduce to the output voltage equation which was examined throughout the study unit. The full derivation is available in the reference text, but just for the sake of completeness for the lecture, the angle gamma is given by the following. So gamma can be expressed in terms of the inductance reactance which is present in each line of the supply, the output current as well as the input voltage, and the delay angle alpha. An important component of the expression for gamma is this term over here. 3 mega L over 2 pi is termed the equivalent internal resistance of the thyristor. An important characteristic of this term is that it is purely inductive, so there is now no power loss or energy loss associated with this term. The set of curves graphically demonstrates the relationship between gamma and alpha. So for a very small alpha, gamma can actually be quite large. And as alpha increases, gamma will become smaller and smaller and smaller until there is some minimal value, after which gamma will start to increase again. The optimal or minimized value of gamma occurs when alpha is equal to pi over 2 or 90 degrees. So to finish up, there are some general effects of the line inductance which cause the current overlap which need to be considered. The first is that the average output voltage is reduced. Secondly, overlap introduces notching in the output voltage. These rapid changes in the current will also cause higher harmonics to be present in the ripple of the output voltage. Overlap also reduces the ability of the thyroresistor to react to changes in current. And finally, the inversion safety angle, which allows for thyroresistor commutation, is increased. And that concludes the study unit. The study unit did cover most of the material in chapter 12 of the text, but the student is still encouraged to work through the chapter, especially for the more lengthy mathematical derivations. These derivations are not difficult, but the mathematics gets quite complex because there are many sinusoidal and trigonometric expressions which just get expanded upon. So it's easy to follow what the mathematics are doing, but to explain the math out loud is actually quite time consuming. And finally, section 12.7 of the chapter provides a convenience summary which summarizes the mathematical structure which is applied when determining what the outputs are and characterizing the various full and half wave, single and three-phase converters and rectifiers. And that concludes this lecture.